something extraordinary is developing beneath the surface of the tropical Pacific Ocean. Thousands of miles away from the United States, an enormous reservoir of warm water is spreading eastward along the equator. Trade winds are weakening. Thunderstorms are shifting across the Pacific. The atmosphere and ocean are beginning to reinforce each other. The result is a rapidly strengthening El Niño that could reshape American weather from the Gulf Coast to California, from the Pacific Northwest to New England. NOAA has already confirmed that El Niño conditions are present. Forecasters expect the event to continue, strengthening through the end of 2026, with a very high probability that it will survive into early 2027. More importantly, NOAA estimates an 81% chance that El Niño will become very strong during the period from October through December. That would place it among the most powerful El Niño events observed since reliable modern records began in 1950. But another forecast goes even further. Berkeley Earth, an independent climate research organization, analyzed 14 forecasting models. Its researchers concluded that the tropical Pacific could reach temperatures beyond anything seen during roughly 150 years of reconstructed observations. The group estimated a high probability that this event could surpass the famous El Niño episodes of 1982 to 1983, 1997 to 1998, and 2015 to 2016. However, NOAA scientists are more cautious. They agree that a very strong event is likely, but they do not claim that it will definitely become the strongest El Niño in 150 years. NOAA has greater confidence in observations collected since 1950 and warns that comparisons with earlier events involve more uncertainty. So, what is actually happening in the Pacific? And what could it mean for the weather in your state? El Niño is the warm phase of a natural climate cycle known as the El Niño Southern Oscillation. Under normal conditions, strong trade winds blow from east to west across the tropical Pacific. These winds push warm surface water toward Indonesia and Australia. Near the coast of South America, colder water rises from the deeper ocean to replace the water moving west. This process is known as upwelling. During El Niño, the trade winds weaken and sometimes partially reverse. Warm water that normally accumulates in the western Pacific begins spreading eastward toward the central and eastern Pacific. As the ocean warms, tropical thunderstorms also move east. That shift changes the distribution of heat and energy in the atmosphere. It can alter the jet stream and influence weather patterns across much of the planet. El Niño does not create every storm, drought, flood, heat wave, or wildfire. Instead, it changes the odds. It makes some weather patterns more likely and other patterns less likely. Its influence on the United States is usually strongest during late fall and winter, when the tropical Pacific has a greater effect on the position and strength of the jet stream. A strong El Niño often strengthens the subtropical jet stream. This fast-moving river of air can carry Pacific storms across Mexico and the southern United States. As a result, areas from California and the Southwest to Texas, the Gulf Coast, and the Southeast may experience a cooler and wetter winter than usual. At the same time, the main storm track may remain farther south. That can leave parts of the northern United States warmer and drier, with less snow in some locations. But these are broad tendencies, not guarantees. No two El Niño events are identical. The exact location of the warmest Pacific water matters. So does the timing of the warming, the strength of other ocean patterns, Arctic conditions, soil moisture, and short-term changes in the atmosphere. Even during a powerful El Niño, weeks of unusual cold can still occur in an otherwise mild winter. A generally wet region can still experience dry periods. A state expected to receive less snow can still be hit by a major snowstorm. Seasonal forecasts describe the average pattern over several months. They cannot tell us whether a specific city will receive a storm on a particular day. For residents of the Gulf Coast and the Deep South, the most important change could be a more active southern storm track. Strong El Niño winters have historically increased the likelihood of above-normal precipitation across the Gulf Coast and southeast. Storm systems moving along the subtropical jet can draw moisture from the Gulf of Mexico. This may produce repeated rounds of rain across southern Texas, Louisiana, Mississippi, Alabama, Georgia, and Florida. Some storms may also bring severe thunderstorms, damaging wind, hail, or tornadoes. The cool season severe weather threat is especially important across the lower Mississippi Valley and parts of the southeast. Unlike spring tornadoes, winter storms can arrive after dark when people are sleeping and visibility is poor. El Niño does not guarantee a major tornado outbreak, but a more active southern storm track can create additional opportunities for unstable Gulf moisture to interact with strong upper-level winds. Residents should therefore pay attention not only to rainfall forecasts, but also to severe weather alerts throughout the fall and winter. More rain could also provide benefits. Parts of the southeast that experience dry conditions may receive drought relief. Wetter soil and vegetation may reduce the risk of large wildfires during the following spring in some areas. However, repeated storms could produce river flooding, flash flooding, saturated ground, and damage to roads or homes. The same rainfall that improves a drought can become dangerous when several storms follow one another. Along the Atlantic hurricane corridor, El Niño may bring a different kind of influence. A strong El Niño normally increases vertical wind shear over parts of the tropical Atlantic. Vertical wind shear means that wind speed or direction changes significantly with altitude. Tropical storms and hurricanes need a relatively organized vertical structure. Strong wind shear can tilt or disrupt that structure, making it more difficult for storms to form or intensify. Because of this effect, NOAA entered the 2026 Atlantic hurricane season expecting below normal activity. The agency originally projected between 8 and 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes. As El Niño strengthened, forecasters became even more confident that Atlantic activity would remain below average. But a quieter season does not mean a safe season. El Niño reduces the average number of Atlantic storms. It does not create a protective shield around the United States. A single hurricane striking a heavily populated coastline can make an otherwise quiet season catastrophic. Storms can also form close to land, especially in the Gulf of Mexico or Western Caribbean, where residents may have less time to prepare. Anyone living from Texas to Maine should continue monitoring official forecasts and maintain a hurricane plan until the season ends on November 30th. California may face one of the most closely watched consequences of this El Niño. Strong events often strengthen and extend the Pacific jet stream toward the west coast. That can guide more winter storms toward California. Some seasonal models are showing a strong signal for above-normal precipitation along parts of the California coast during the winter of 2026 to 2027. The greatest effects would most likely appear during the middle of winter, when El Niño normally reaches its peak influence. Southern California could receive more frequent rainstorms. Central and Northern California could also see wetter conditions, depending on the exact position of the jet stream. But the relationship between El Niño and California rainfall is not perfectly consistent. Some El Niño winters have produced extreme rainfall, others have disappointed forecasters. The strength of the event matters, but it is not the only factor. The precise location of warm Pacific water and the path of individual atmospheric rivers can determine which areas receive the heaviest precipitation. If the wettest forecasts become reality, the benefits could be significant. Reservoirs may gain water. Mountain snowpack could improve in some areas. Dry vegetation may receive moisture, reducing wildfire danger during parts of the following season. However, a warmer atmosphere also means that more precipitation may fall as rain instead of snow at lower and middle elevations. A higher snowline can create flooding problems. Rain falling on existing snow can rapidly release water into rivers and streams. Communities near recent wildfire burn scars may face an especially serious danger. Wildfires remove vegetation and change the structure of the soil. When intense rain falls on burned terrain, water can rush downhill with mud, rocks, trees, and debris. A storm that produces ordinary street flooding elsewhere could trigger a life-threatening debris flow near a burned scar. Coastal communities could also face erosion, large waves, and flooding if strong Pacific storms arrive during periods of high tide. Therefore, a wet winter would not simply mean drought relief. It could bring a dangerous transition from fire to flood. Across Arizona, New Mexico, southern Nevada, and parts of the southern Rocky Mountains, El Niño often increases the chance of winter precipitation. Rain in lower elevations and snow in the mountains could improve water supplies and reduce drought in some areas. The Colorado River system could benefit if storms deliver substantial mountain snow. But one winter alone cannot erase long-term water challenges across the Southwest. Reservoir conditions depend on years of snowfall, temperature, evaporation, and water use. A strong El Niño could provide temporary improvement without solving the region's deeper water imbalance. The Southwest must also consider flooding. Desert soil often absorbs water slowly, especially during intense storms. Dry washes can fill rapidly, and roads crossing low areas may become dangerous. Drivers should never attempt to cross a flooded roadway, even when the water appears shallow. In the Pacific Northwest, including Washington, Oregon, and northern Idaho, the expected pattern is almost the opposite. Strong El Niño winters often bring warmer temperatures and below normal precipitation to parts of the region. Mountain snowpack may be lower than usual, especially at lower elevations where warmer conditions cause more precipitation to fall as rain. Reduced snowpack can have consequences that continue long after winter ends. Mountain snow acts as a natural reservoir. It stores water during winter and slowly releases it during spring and summer. When snowpack is low, rivers may receive less water during the warm season. That can affect agriculture, hydropower production, fish habitat, and municipal water supplies. A warmer and drier winter could also allow vegetation to dry earlier in the spring, potentially increasing wildfire risk in the northern Rockies and parts of the Northwest. However, local differences will be important. A storm track shifted only a few hundred miles can change precipitation dramatically. Some mountain ranges may still receive heavy snow even if the broader region finishes the winter below average. Across Montana, Wyoming, the Dakotas, Minnesota, and other parts of the northern United States, El Niño often reduces the frequency of prolonged Arctic cold. This does not mean winter disappears. Cold waves can still move south from Canada. Blizzards can still occur. Temperatures can still fall far below freezing. But over the entire season, northern states may experience temperatures above their long-term average. Less persistent cold can reduce heating demand and make transportation easier during some periods. At the same time, warmer winter temperatures can create unstable freeze and thaw cycles. Snow may melt during the day and refreeze at night. Ice conditions on lakes and rivers can become less predictable. Agricultural pests that normally die during severe cold may survive in larger numbers. The northern Rockies may also receive below normal snow in many locations, although some parts of the central Rockies could experience increased snowfall depending on the storm track. The Ohio and Tennessee valleys sit near a complicated transition zone. Historically, parts of the Ohio Valley have tended to be drier during El Niño winters because the strongest storm track is often displaced farther south. The Tennessee Valley may experience a mixture of influences. Some areas could finish the winter drier than normal overall, while still facing episodes of heavy rain or severe thunderstorms when southern storm systems move through. This is an important distinction. A season can be classified as dry even if it contains 1 or 2 damaging floods. Seasonal totals do not reveal how the rain was distributed. Several weeks without precipitation, followed by one extreme storm, can create both drought and flooding problems during the same season. The Great Lakes region may experience warmer conditions and reduced snowfall, especially when temperatures are too high for lake effect snow. Lake effect snow develops when cold air passes across relatively warm lake water. If Arctic air outbreaks become less frequent, some traditional snowbelt communities may receive less snow overall. But warmer lakes can also remain unfrozen longer. When a strong cold outbreak finally arrives, the open water may provide enough moisture to produce intense local snowbands. This means that total seasonal snowfall may decline, while individual events remain disruptive. In the Northeast, El Niño often favors a milder winter, but snowfall patterns are more complicated than many people realize. Northern New England frequently receives less snow during El Niño events. Interior regions and areas near the Great Lakes also tend to show a reduction. However, parts of the mid-Atlantic can sometimes receive above normal snowfall during certain El Niño winters. The reason is that the southern jet stream can supply abundant moisture. If cold air is positioned over the east coast at the right moment, a moisture-rich storm can produce heavy snow. El Niño can also support powerful coastal storms, commonly known as nor'easters. These storms may bring heavy rain, snow, strong winds, coastal flooding, and dangerous waves. A generally mild winter does not prevent a major East Coast snowstorm. Washington, Baltimore, Philadelphia, New York, and Boston could experience long periods of moderate weather followed by one high-impact coastal storm. That is why seasonal averages should never be confused with daily weather forecasts. El Niño may also influence Alaska and Hawaii. Much of Alaska tends to experience warmer conditions during El Niño winters. Reduced sea ice and unusual ocean temperatures can intensify some of these effects, although local patterns vary greatly across the state. Hawaii can sometimes experience drier conditions during the wet season, increasing concerns about drought and wildfire. El Niño also tends to increase tropical cyclone activity in the eastern and central Pacific. That does not mean Hawaii will necessarily be struck by a hurricane, but more storms forming in the central Pacific can increase the number of systems that require close monitoring. Beyond local weather, a very strong El Niño could influence global temperature. El Niño releases heat from the tropical Pacific into the atmosphere. Global average temperatures often rise during the event or in the months after it reaches its peak. However, El Niño is occurring on top of long-term human-caused climate warming. The natural cycle creates temporary changes from one year to another, while greenhouse gas emissions raise the long-term temperature baseline. This combination means that even familiar El Niño patterns may now occur in a warmer atmosphere capable of holding more moisture. Warmer air can increase the amount of water available to intense storms. Higher temperatures can worsen heat waves and increase evaporation during dry periods. This does not mean climate change causes El Niño. El Niño has occurred naturally for thousands of years. But climate change can alter the background conditions in which El Niño operates, potentially increasing some of its consequences. The most important message is not that every state will experience a disaster. It is that the odds are shifting. The Gulf Coast and Southeast may face a wetter, stormier cool season. California and the Southwest may receive needed rain, but also face flooding, debris flows, and coastal damage. The Pacific Northwest and Northern Rockies may see a warmer winter with reduced snowpack. The northern states may experience less persistent cold. The Ohio Valley could be drier overall. The Northeast may be milder, while remaining vulnerable to powerful coastal storms. And the Atlantic hurricane season may be quieter than normal, without eliminating the danger of landfall. Scientists will continue watching ocean temperatures, subsurface heat, trade winds, atmospheric pressure, and tropical thunderstorms during the coming months. NOAA's next updates may adjust the expected strength and duration of the event as new observations arrive. What we know today is that El Niño is already present. It is strengthening rapidly, and the probability of a very strong event is unusually high. What remains uncertain is exactly where the most serious consequences will appear. A powerful climate pattern does not write the weather forecast for every city. but it loads the atmosphere in a particular direction. For millions of Americans, the winter of 2026 to 2027 could be warmer, wetter, drier, less snowy, or more stormy than usual depending on which side of that shifting jet stream they live. The changes are beginning in a distant stretch of the Pacific Ocean. Their effects may soon arrive at America's doorstep.